So if you watched my video on YouTube, you know that we're going to talk about primary colors and secondary colors, maybe a little bit about complementary colors. I'll tell you what all those different things mean. And then we've got a little experiment to look at color mixing. And then, as I mentioned just a few minutes ago, if you were here, we're going to try and make some paint. And this was actually Sarah's idea, trying to make paint out of things that you've got in your kitchen. And then when I looked into it, I found out that people have been doing that for literally thousands of years. Like the ancient Egyptians used to paint their mummy cases with stuff that just comes out of your kitchen. So I thought that was pretty cool. We should definitely give that a try. So that's what we're going to get to towards the end here today. But to start us off, we're just going to talk about our different types of colors. So our primary colors are our yellow and blue and green and red, as you can see in front of me. So they're called the primary colors because these ones can't be made of any other colors. So you can't mix any other two colors together to get these. If you want these colors, you have to find something blue, find something yellow, or find something red. So if you wanted to paint something with these colors, you just need to have a yellow paint or you need to have a red paint. There's just nothing you can do about it. You can't combine anything else to make them. But if we put these colors together, they can give rise to our secondary colors. So now it's green and orange and purple, or sometimes called violet. So we can see the mixing. It's a little easier with these paddles. I don't have to get into mixing anything up. If we look at red and blue, you can see that it does in fact make purple. And if we put our red and our yellow together, it makes orange. And our yellow and blue, we get green. So when you want to make those colors, if you're an artist, you're in luck. You can just put two together and make your colors. Now, complementary colors, on the other hand, you're going to figure those out by actually putting your colors all on a wheel. So our primary colors, yellow, red, and blue. And then if you say, well, what happens if you put red and blue together? You get purple. So you put purple in between red and blue. And what is purple right across from? Yellow. So purple and yellow, those are complementary colors. We go over here, your blue and your yellow go together and make green. And then what's right across from green is red. So red and green are complementary colors. And this is kind of a sad looking orange. It looks a little bit more like brown because my orange marker was kind of dying. But that is what you find when you go between yellow and red. You get your orange, and right across from that is blue. And our complementary colors are basically our colors that just look really nice against each other and they really pop out. And that's because this color here is made up of these two, but it's got no yellow in it at all. So they really contrast with each other. They're really, really different. And this one here is made up of these two. It's got no red in it at all. So when you put an extra red, it really pops out. And that's probably why we put those two colors together at Christmas, since they're really, really nice looking. I think really that yellow and purple kind of like Easter colors almost. They really pop. I don't know about blue and orange. Maybe the Edmonton Oilers are blue and orange. So those colors really pop too. So that's what we mean when we say complementary colors. And these are just things that you have to sort of pay attention to or think about when you're creating artwork, when you're designing things, when you're painting things. And it has to do a little bit with the way that your eyes actually see the colors. So the way your eyes work is you have little cells in the back of your eyes, and they basically light up and they pick up color. So when light goes into your eyes, it hits the cells, and those cells tell your brain, hey, we saw a color. And so we have our primary colors, as we mentioned, like red and yellow and blue. And so what's happening here is this bowl looks blue because the light is coming from maybe a light bulb or maybe from the sun, and it's coming in and goes, it hits the blue bowl. And then inside the light is every color in the rainbow. So that's all of our colors. But the only color that comes back after hitting the bowl is the blue. So all the light waves come and hit the bowl, and then a bunch of them just kind of absorb into the bowl. But the blue ones, they reflect off and they come right into your eye. And the same thing happens with the red ones. All the light waves come flying out of the sun and they kind of go, and then a bunch of them go and absorb into the cup, and just the red ones come flying off the cup and hit you in the eye. And then your eye lights up, just the red cells in the back, and tells your brain, hey, we see something red. Now, of course, the same thing happens with our secondary colors. So in all these cases, we're just getting one wave of light. And if you've ever seen a rainbow, you've seen all those different colors that kind of go across the rainbow. I can't actually show you a rainbow right now. I could do it in person, but it actually doesn't show up properly when you try to do it. The little like sort of camera that's inside any of these streaming devices is not actually able to pick up the rainbow. So we all just have to remember what a rainbow looks like. It's got all those stripes of color in it. So each one of those can come sort of flying out, hit you in the eye, and you'll see a different color. But we don't just see colors, do we? We can also see black and white, right? And black and white are not inside the rainbow, so what's going on there? Well, it's kind of cool, it's kind of special. So when we're seeing colors, that means that one of those little types of lines inside the rainbow comes flying out at us and we can see it. When we see white, it means every single type of light is coming out at the same time. So when you look up at the, don't look too closely at them, but when you look up at our light bulbs, they're giving off white light. That white light is coming out and it hits something, and all those colors at the same time reflect back into your eye, and it all comes out as white. On the other hand, if they hit something black, that means none of the light escaped and it all got absorbed into this. So with red, every color except red got absorbed and red came bouncing back. With black, every single color gets absorbed in there and nothing comes bouncing back. So you can think of black as being something that no light can escape from, and you can think of white as something that all the light escapes from. The light just hits it and goes up into your eye. No big deal. Now, the only other thing you might want to know about this is that the light, as it's traveling, comes sort of in a wave. And some of the wavelengths are really long, so the light goes, ooh. And some of them are really short, so it goes, ooh. And when it's really long, then each little particle of light is a little bit stronger. And when it's really short, then each little particle of light is not quite as strong. It doesn't quite have as much electricity in it, if you will, as much voltage. So we have light on our visible spectrum, which just means we can see it. And then there are also waves that are a little bit lower than red. We call them infrared. And so if you've ever seen maybe when you were out with pop hunting or something like that, if you've ever seen something that can see the heat that's coming off of your body, that's infrared. So that's actually seeing waves that your body gives off in the form of heat, not in the form of color, so we can see. And if you've ever had a sunburn before, that means that your skin got hit with ultraviolet light. That's the light that, or those are the waves that are just a little bit smaller than the ones you can see when you see the color purple. So all of the light and colors that we see are just a little skinny bit of the waves that come off of the sun. And some of the waves that come off the sun are also heat, and some of the waves that come off the sun are also ultraviolet, and they give you a burn if you're not wearing your sunscreen. So that's just a little bit about the physics behind the colors that you see, and a little bit about how they work inside your eyeball. But if you don't quite understand how they work inside your eyeball, that's okay. It's very complicated. Even the people that have been studying it for the past 200 years do not quite understand how it works. So don't feel too bad about that. All right, so I just want to show you something kind of cool. I believe it will work through the camera that's attached to our iPad here. It did work earlier when I tested it. So I made this little color wheel, and this is just our primary colors here. And so, as I said before, light that's hitting these yellow patches here is all of the lights being absorbed except the yellow light, that's getting reflected back. On the blue patches, the blue light is getting reflected back. And on the red patches, the red light is getting reflected back. And your brain picks up all those signals and tells you, oh, look, I see a wheel with blue and red and yellow on it. But when this starts moving really fast, then all of that light coming back into your eye at the same time, your brain can't really pick out that there's a little bit of red coming and a little bit of blue coming and a little bit of yellow coming. It just sees a whole bunch of light. And so what's going to happen is it's going to just look white, because when your brain detects a whole bunch of light, it just understands it as white. It's got to get going pretty fast. So I'm actually using a pretty strong battery to make it happen. If you try to make one yourself, it's hard to get it to spin fast enough to actually trick your brain, because your brain is pretty fast. And it really wants to see those colors. We have eyeballs that are really trained to look for colors. So you can try to make one yourself if you like, but it might be hard to get it going fast enough that you actually get the effect of things starting to turn white. I had to use our little battery-powered fan to do it. But that's a little way you can sort of trick your brain, or in a sense, you sort of overload your brain's ability to figure out what's going on and process what's going on. Your brain can only move so fast, and lots of optical illusions work that way. Your brain just kind of gives up, or it kind of cheats a little bit and says, I'm not really sure what I'm seeing here. It's a little bit difficult to figure out. So it comes up with a different way and it tells you, maybe I see this, and you just have to believe it. What can you do? Even though you know there's a bunch of colors in there, you have to admit it just kind of looks white. So that's your brain trying to figure out colors a little bit. Now, we have a little experiment that we can do together that you guys can do at home, I imagine, because all you need for this one is markers, coffee filters, and a little bit of water. So this is a technique that's called chromatography. It's something that chemists do when they want to understand all the different compounds, all the different things that are inside a mixture. And so what I've done here is tried to separate out the colors that make up brown. Brown is the other color that we haven't talked about yet. So we talked about our primary and secondary colors. We talked about white and black, but what about brown? So if you want to know what colors go together, what you can try to do is use water to separate them back out again. So all you got to do here is take usually a dark colored marker like a brown or a black or a gray, and you just take your coffee filter and just kind of draw in the middle of it. You just want to put a bunch of your marker ink on the middle. So it doesn't really matter what it looks like. I'm going to draw like a heart maybe and color it in and like some polka dots around it. You just want to put lots of ink there on your filter. That looks good to me. There we go. And once you've done that, you're just going to take a jar or a cup. You're going to put a little bit of water in it. And then I would say fold it a couple of times so you get kind of like a little point in the middle here. So 1, 2, maybe 3 times. So the ink is down here at the bottom. And then you're just going to dip it a little bit in the water. And what's going to happen here is the water is going to start climbing up. And as long as you use washable markers, then the water is going to pick up the ink from your marker and it's going to start pulling it up as it goes. And this is called capillary action. It's something special that water molecules can do because water molecules stick to each other just a little bit. So as they start to go up, they kind of pull each other up and the water molecules start traveling up and up and up. And as they go, because these markers are washable, that means that water will pick them up as well. The water starts to pick up the ink and pull it along. And it will take a couple minutes, but what you'll get in the end when you unfold it is sort of the trail that the water followed and the molecules that pulled along with it. So you see there's still a little bit of brown there. The brown didn't totally get pulled apart by the water, but the water managed to pull the brown into a little bit of orange and a little bit of purple. So probably if you want a nice brown color, you got to mix orange and purple. That would be our conclusion from our chromatography. And people do chromatography on all sorts of different things. You could try it with many different things that are dyed. You could try it with Skittles and M&Ms and things like that, things that have got different colors in them. Markers are probably the easiest. And now, of course, you can give it a try with, say, blue, if you wanted, or red. But we know that those are our primary colors. So no matter what, we're not going to be able to pull any other colors out of these ones. Yellow is just made of yellow, and red is just made of red. So you'll just end up with a circle around here that just looks red or yellow. So we can give it a try if we want, just to double check. But as far as we know, there are no colors in the world that you can combine together to make red. So when we separate red all out, all we should be able to see are just different types of red. But it's always worth experimenting and double checking, right? All right, so put some red on that one. Give it a try. How's my orange? Oh, whoa, whoa. You don't want it to get totally dunked. You just want a little bit of it in the water so the rest of the water can travel up. So you might have to hold it or like fold it over so that it doesn't fall in. There we go. All right, now I'll do the red one just to check. And it might be kind of cool too if you have different kinds of markers there to see if each kind of brown marker is made up of the same colors. So you might have, we've got Crayola in here, and we've got Rose Art, and we've got something that all the colors washed off of. So you could try different types of markers. You might find that the Crayola company mixes their colors as this sort of orange and purple, but maybe the Rose Art company mixes together green and purple to make brown, and maybe they have a slightly different kind of brown. So it might be kind of cool to investigate. So whatever kinds of markers you've got at home will still give you some pretty interesting results, however you decide to do it. All right, there's red. See how our brown is making out. Now when you unfold it, it's going to be pretty delicate. So just be careful with it and just let it dry slowly. This one we can't see quite as much purple on, but it hasn't dried yet. So I think the purple will come out a lot stronger once it dries. Right now, our little filter is pretty wet, so it's pretty see-through, but there's still a little bit of purple in there and still a little bit of brown. And it shouldn't take too long to dry. Now, one fun thing you can do also once you're done this experiment, which is extra fun, is you can turn them into like little butterflies. So if you've got pipe cleaners at home or twist ties, you can sort of bunch them up and turn them into little butterflies. That's kind of cute too. So if you want to play around with that and experiment with that, then you get your scientific data, but you also get some cute little butterfly crafts out of it too. So it's kind of like a double whammy. And we'll look at our red. It doesn't look like any other colors are going to come out of it, but we'll let it dry for a sec just so we can be sure, and we'll come back to it. Okay, so I got a couple of these drying now before we can really see the results. We don't want to jump to any conclusions before they're dry, so we'll leave them for now and move on to our next thing. We'll come back to that at the end.